Hello everyone, welcome to the video series of measurement and instrumentation. In today's video, we are going to discuss the topics on unit 2, which is measurement of power, energy and magnetic measurements. In unit 1, we have discussed about measurement of voltage and currents. In this video, we are going to see about the instruments that are used for measuring power, energy and magnetic measurements. So we will start with the measurement of power. So power is measured using wattmeter. A current is measured using ammeter. A voltmeter measures voltage. Power is measured using wattmeter and energy is measured using an energy meter. So the basic type of wattmeter that is used to measure power is an electrodynamometer type wattmeter. So we have already discussed about the dynamometer types instruments, which are the EDM type instruments, which are very similar to the PMMC, but with the difference that the permanent magnet is being replaced by the fixed coils. So the basic action of this instrument depends upon the electromagnetic force exerted between the fixed and moving coils. Since it is a wattmeter, you have a fixed coil and a moving coil. One is the current coil, the other one is the pressure coil, or you can say it as the potential coil. So here is the circuit diagram for electrodynamometer type wattmeters. So you have the fixed coils and the moving coil is connected in shunt with the system, and with the moving coil, which is denoted by M, to which the pointer is being attached, which moves over the scale. The moving coil is connected in parallel to the supply through a high resistance R. The current coil is connected in series to the load, whereas the moving coil is connected in parallel to the load. So now let's see the working. So the fixed coils denoted by FF and the moving coil M are carried by the spindle. The controlling torque is provided by two spiral springs mounted on the spindle, which acts as the leads to coil M. The deflecting torque is proportional to the product of the current in the coil and voltage and pressure across the pressure coil. So power, as we all know, P is equal to V into I. Also, the deflection torque produced will also be a product of the current in the current coil and the voltage in the pressure coil. Therefore, TD is proportional to the power. The scale of this instrument is uniform, and this EDM type wattmeter is used for measuring both power in AC and DC circuits. The main advantages of this EDM type instruments are, as already discussed, it is used for both AC and DC measurements. The construction is very simple, and since it is not involved with any ion instruments, any ion materials, the instrument is free from hysteresis errors, and it has a uniform scale. The weight is light and it consumes very less power, which is of very negligible value. So for any measuring instrument, if it is used in a circuit, it has to consume less power because it should not alter the normal operating condition of the circuit. Similarly, this EDM wattmeter, which is meant to measure the power, should not consume more power, which in turn becomes an error in showing the reading. So these EDM wattmeters will consume only less powers. Let's see the disadvantages. The main disadvantage is it is high cost because we are using two fixed coils, and also the errors can occur due to friction, changes in temperatures. So these EDM wattmeters are highly sensitive to temperatures, hence whenever there is a change in temperature in the environment, it will show a deflection. corresponding to it, so it affects the reading also. And also, these EDM power factors are not good when used for low power factors, so it shows very large errors. So these EDM instruments can be used for measuring powers with high power factors, where the power value is high and the current value is less. It also gets affected by external stray magnetic fields, as we discussed in unit 1 also. So shielding is very essential for this EDM type wattmeters. So this is the basic of an EDM type wattmeter. Hope it is very simple and very easy to understand, and also the circuit diagram is also very easy. So I think this topic is very easy to understand. Hope we'll meet you in the next video with another topic. Thank you. Thanks for listening.